Hello friends, welcome back to our YouTube channel, Civil Stories. Here, you will find informative videos related to civil engineering discipline. Today, in this video, we are going to discuss about various mechanical properties of materials. The mechanical properties of materials play very important role in engineering applications. To finalize specific material for application, it is important to understand their behavior, mechanical properties under different loadings. Mechanical properties of any material refers to those which affect the mechanical strength of material, and possess the ability to get deformed or can be molded in any form or suitable shape. Some of the typical mechanical properties of a material are strength, toughness, hardness, brittleness, malleability, ductility, creep, resilience, fatigue. Strength. It is the property of a material which resists the deformation or breakdown of material in presence of external forces or loads. Its numerical value is determined by the amount of force per unit area. Its unit is Newton per square meter. Materials which are finalized for engineering applications must have suitable mechanical strength to be capable to resist different mechanical forces or loads. Toughness. It is the ability of a material to absorb the energy and gets plastically deformed without cracking or fracturing. Its numerical value is determined by the amount of energy per unit volume. Its unit is joule per cubic meter. Value of toughness of a material can be determined by stress-strain characteristics of a material. For good toughness, materials should possess good strength as well as ductility. Hardness. It is the ability of a material to resist to permanent shape change due to external stress. The SI unit of hardness is Newton per square millimeter. There are various measures of hardness: scratch hardness, indentation hardness and rebound hardness. Scratch hardness. It is the ability of materials to resist the scratches to outer surface layer due to external force. Indentation hardness. It is the ability of materials to resist dent due to punch of external hard and sharp objects. Rebound hardness. Rebound hardness is also called as dynamic hardness. It is determined by the height of bounce of a diamond-tipped hammer dropped from a fixed height on the material. Brittleness. Brittleness of a material indicates how the material gets fractured or cracked when it is subjected to a force or load. When a brittle material is subjected to a stress, it absorbs very less energy and gets fractures without significant strain. Brittleness is converse to ductility of the material. Brittleness of material is temperature dependent. Some metals which are ductile at normal temperature become brittle at low temperature. Malleability. Malleability is a property of solid materials which indicates how a material gets deformed under compressive stress. Malleability is often categorized as an ability of material to be formed in the form of a thin sheet by hammering or rolling. This mechanical property is an aspect of plasticity of material. Malleability of material is temperature dependent. With rise in temperature, the malleability of material increases. Ductility. Ductility is a property of a solid material which indicates that how the material gets deformed under tensile stress. Ductility is often categorized by the ability of material to get stretched into a wire by pulling or drawing. This mechanical property is also an aspect of plasticity of material and is temperature dependent. With rise in temperature, the ductility of material increases. Ductility is measured by determining the percent of elongation and the percent reduction of area on a specimen during a tensile test. Creep. Creep is the property of a material which indicates the tendency of material to move slowly, and deform permanently under the influence of external mechanical stress. It results due to long-time exposure to large external mechanical stress within limit of yielding. Creep is more severe in material that are subjected to heat for a long time. Units are in per hour, or percent of elongation per hour. Resilience. Resilience is the ability of material to absorb the energy when it is deformed elastically, by applying stress and release the energy when stress is removed. Proof resilience is defined as the maximum energy that can be absorbed without permanent deformation. The modulus of resilience is defined as the maximum energy that can be absorbed per unit volume without permanent deformation. It can be determined by integrating the stress-strain curve from zero to elastic limit. Its unit is joule per cubic meter. Fatigue. Fatigue is the weakening of material caused by the repeated, cyclic, loading of the material. When a material is subjected to cyclic loading, and loading greater than certain threshold value, but much below the strength of material. Ultimate tensile strength limit or yield stress limit, microscopic cracks begin to form at grain boundaries and interfaces. Eventually the crack reaches to a critical size. This crack propagates suddenly and the structure gets fractured. The shape of structure affects the fatigue very much. Square holes and sharp corners lead to elevated stresses where the fatigue crack initiates. The SI unit of fatigue is N per square millimeter. That's all for today, friends. Hope you have found this video useful and informative. For more videos, kindly subscribe to our channel and don't forget to press the bell icon to receive latest updates. Thank you.